All right, so section B, use base E to solve exponential and log functions. So before we start, we need to go over what the heck E is. So E is a number, okay? It is about 2.71, okay? And if you want the exact number, you on your calculator, you press seconds and an ln just to the left of the number 4, and you get E, okay? So e to the power of 1 is going to be 2.718281828, and it goes on forever and ever, like the number pi, okay? So whenever you see E, that's a number, okay? It's 2.71 about, and we use that for things that are natural, things that are continuous, okay? The reason we have E is because things don't just magically appear or disappear, okay? For example, you guys didn't just like magically become high schoolers. You had to go through elementary school, middle school, and then high school, right? So that's a continuous process. That's natural. What's not natural would be, so for example, you put $100 to a bank account and it's 5% interest. So you're expecting 5% of $100 at the end of the year. Now, what happened in between that year? Well, if you go to the bank halfway through the year, 6 months, right? You don't have anything, but then all of a sudden after 1 year, it magically appears, okay? So that is unnatural. We will not be using natural base E in that case, okay? But things that are continuously growing, continuously decaying, we will be using E, okay? For exponentials as well as logs, okay? So question number 5. A patient is injected with a radioactive tracer for a medical scan. The amount of the tracer remaining in their bloodstream, A, in milligrams, decreases continuously. Okay, so that's the key word right there, continuously, over time in hours, according to the function. Okay, so notice how this function has the E. That makes sense because this is continuous, so we should see an E somewhere in there. Part A says the scan can only occur when the tracer drops to 5 milligrams. How long do they have to wait? Okay, so my A of t right here is going to be 5, and 5 is equal to that function that we were given. So 15e to the power of negative 0.12t. Okay, so the first step that we need to do is try to get to that t, okay? Right now, we have to work outside before we can go into that exponential. So right now, what's in the way is that 15. So we're going to go ahead and divide 15 on both sides, okay? So that's going to be 1 over 3 on the left side, and on the right side, we still got that e to the power of negative 0.12t, okay? So something you need to realize is when it comes to natural base e, its inverse is log base e. Okay, so log base e is going to be the inverse of e. Okay, so if I had something like this, notice how we have the base e for the log, and for this one, the exponential has a base e. Okay, now the answer for this case would be 1. Okay, because what happens is if I have a log, and inside that log, inside the parentheses, is an exponential, they cancel each other out because exponentials and logs are inverse of one another, okay? And in this case, it looks like what's left is that 1 from e to the power of 1, okay? So keep that in mind while we're trying to solve this, okay? So you want to get rid of that e, we have to go ahead and do log base e on both sides. However, there's a special way we would write anything that has log base e, okay? We don't write it as log base e. That just looks weird, and it takes a lot more time because there's so many letters, right? So what mathematicians do is they just write ln of x instead of log base e of x, okay? I guess this is just a couple letters you don't have to write, okay? So this is specifically for any log with a base e, okay? So we're going to go ahead and use that for our problem. So to get rid of that e, just go ahead and ln both sides effectively. So ln of 1 over 3 ln of e to the power of negative 0.12 t, okay? So again, because ln has that base e, that cancels out with this base e because of that exponential, okay? So we have left over negative 0.12 t is equal to that ln of 1 over 3, okay? To find our time, divide both sides by negative 0.12, negative 0.12, and then we get our time is, okay, so let's use our calculator because there's no way we can solve this without it. Okay, so ln is right to the left of the number 4 right here. So ln of 1 divided by 3, close the parentheses, and we're dividing that by negative, so please put down the negative, not the minus, 0.12. Press enter, and it's about 9.15 hours, okay? So you would tell that patient, hey, I'll meet you in about 9 hours, okay, for the scan. So let's move on to question B. What does the y-intercept represent? Okay, so the y-intercept in any situation is when x equals 0, okay? In this specific problem, x is going to be our time, or t, okay? So that's when t equals 0, okay? So when the time equals 0, or when the starting point is, that's when we have x equals 0. So the answer here is it's when we start the timer, okay? So starting point is that y-intercept. It's when x equals 0, okay, when we start the time, okay? So point or starting time, okay? And that's really important to know because your patient might not know what the heck the y-intercept is, so you have to translate it to plain English. It's the starting point or starting time, okay? Let's move on to question number 6. A new social media platform tracks how many influencers join the site. The total number of influencer n of x after x weeks is modeled using this function, okay? What is the number of influencer at the starts? Well, that's when x equals 0. Remember, that's the y-intercept that we just did for part B in that last question. So when x equals 0, what's your answer? Well, I'm just going to go ahead and plug it in. So n of 0 is equal to 50 plus 100 ln of 0 plus 1. That's just 1, okay? So real quick properties of logs for a sec. Whenever you have a log and the inside of that parentheses is the number 1, you're going to get a 0 out of that. So this is going to be 0, so it's 0 plus 50, so the answer is going to be 50. Okay, now how do I know that? Is because let's just go ahead and write this as log of e of 1, okay? So let's use the loop-de-loop method. So e to the power of what makes 1? Well, anything to the power of 0 makes the number 1, okay? Let's do another one. Log of 4 to the power sorry, not log to the power of, log base 4 of 1 is equal to something. Okay, well, what 4 to the power of what makes the number 1? Well, that's going to be 0 again. Do you see how, like, whenever you have something in the parentheses and it's the number 1, right? Just the number 1, the answer is going to be 0. Okay, so I didn't even have to use a calculator for that one. But let's just say you've totally forgot that property of logs, okay? You can use a calculator. That's fine. So 50 plus 100 ln of 1. Press enter, and it says 50, okay? So please, if you are struggling, use your calculator. It's available for to you. So let's move on to part B. Once there's n of x equals 400, we can monopolize or monetize. So how many weeks does that take? All right, so we're going to set n of x equal to 400. So 400 is equal to 50 plus 100 ln x plus 1. And we're trying to get to that x, okay? Now, you have to work outside before you can go in. And outside right now is that 50. So subtract 50 on both sides, and you get 350 on the left side. But then you got that 100 too. So divide both sides by 100. So you have 350, which let's go ahead and simplify that to 35 over 10 is equal to ln of x plus 1. Okay. So remember, ln is just log base e. Okay. So we have a base e for ln. Okay. And exponentials and logs cancel each other out. So I really want to get rid of this ln, or log base e, okay? I could do that by making this part of an exponential, okay? So the base that I want to use is going to be e. So I could go ahead and just make both sides e to the power of this to get rid of that ln. Okay, so once I do that, I can go ahead and isolate the x. Okay, so we have e to the power of 35 over 10 is equal to x plus 1. Now, the reason why I got x plus 1 here is because the ln canceled out the e. Okay, and so all we have to do now is just minus 1 on both sides. So x is equal to, let's just go put that in the calculator. So we have seconds ln of 35 divided by 10 is 33, and if I took out 1, it's 32. So it's about 32 weeks in that we, will be able to monetize, okay? So biggest thing here is you need to understand that e is a number, okay? And we don't write the inverse of e as log base e, okay? We write it as ln of x, okay? So just be aware of that. If you see ln, that's just a base e for the log, okay?